So in this problem, we're told that a long plank of length d and mass big M is supported at a distance d over 4 and has a mass little m hanging off of the other end. We're asked what the mass little m will have to be in order to hold the plank in equilibrium in part A. And in order to solve this, all we're going to do is we're going to note that the center of mass of the plank lies at a distance d over 2 from the end of the stick, which is a distance d over 4 from the support point. We're going to use the support point as our point of reference because that's the point that the plank will be tipping around. And so we know that gravity acts as if it was a single force acting upon the center of mass. And so if we have the force of gravity, mg, acting at the center of mass, then this tension force from the mass little m, which will be equal to little mg, will have to also be equal to big mg in order to completely cancel out the torque from this force of gravity. Because their distances r are the same on either end, which means that they have to apply the same force since they are also both perpendicular to the distance vectors. So this tells us that in order for the system to be in equilibrium, little m will have to be equal to big M. Now in parts B and C, we're asked what will the directions of the torque vectors due to the tension from this mass and due to the force of gravity be. Now we know that torque is equal to r cross F. So that tells us that we can use the right-hand rule for the radius and the force in order to determine what direction the torque vector will be pointing. So in the case of this tension right here, the radial vector points in this direction. The force points straight downwards. So that tells us that r cross F is going to be pointing out of the board. For the other one, the force of gravity, r is going to be pointing in this direction, and the force is again going to be pointing straight down. So we can curl our fingers using the right-hand rule again, and the torque vector is going to be pointing straight into the page. So those are our answers for B and C. The torque due to tension is going to be pointing out of the page, and the torque due to gravity is going to be pointing into the page. And we know that the mass little m is equal to the total mass, big M, of the plank in order for the plank to reach equilibrium.